All right, let's get started. Hi, everybody. Good afternoon. I'm Lily Fitzgerald. I am the director of the Center for Advanced Manufacturing at MassTech. This morning, you heard from the governor of Massachusetts, Maura Healey, and illustrated some of the incredible leadership that the state is taking on climate change. I represent another part of that mosaic, and specifically how we manufacture and scale technologies to decarbonize industry. And industry is, of course, one of the singular largest producer of greenhouse gas emissions, the biggest issue that we have, some fundamentally difficult to decarbonize sectors of industry. Cement, steel production, chemicals are really challenging things to produce sustainably, as we know. And so I represent part of the state that's funding the manufacturing of alternative technologies, and I'm really excited to be here today with three innovators on the cutting edge of these new transformative technologies that we desperately need to scale. So against that landscape, I'm going to start with you, Jose. So I think it's quite clear that we need to decarbonize the industry and create scalable and just infrastructure. Can you tell us about what role Fluorent is playing in that transition?
Absolutely. Hello, everyone. My name is Jose LaSalle. I'm the co-founder and CEO of Fluorent. We make supercapacitors. These are power storage mediums for grid stabilization. We're supported by MassTech as well as Forge in a number of ways. So great to be here with you all. And for us, the role that we see, well, a quick background on our business, really we're trying to prove out this thesis that we can take waste material and convert that into these high-performance products that help enable the wider adoption of renewables in a decarbonized world. And from what we're learning from our customers, who are grid-connected equipment OEMs and integrators, we're learning that decarbonization of generation, as well as electrification of industrial processes, is an inevitable thing. And that's primarily driven by cost reduction and a drive down in the cost curves here. And so it's an economic solution, in part thanks to some great innovations in the field, such as what Francesco is building. And what we do here is, for example, pair with renewables to make it look like a thermal generator. So a big problem with renewables is that they have what's called low inertia. This means that they're not able to instantaneously respond to voltage and frequency swings when we have industrial facilities that have electrified coming online and having incredibly dynamic loads challenging the grid. And so what supercapacitors provides is what's called grid forming to make them look like thermal generators. So that's the role that we are playing here.
Awesome, thanks so much. Shameless plug, since I have the microphone right now. Jose's company, Fluorent, receives one of the grants out of my agency called M2I2, which is for scaling up these hard tech solutions. And the last 2 years alone, we made 14 investments in the climate tech space of totaling about $13 million. And so if you have a solution like what's on stage today, please reach out to me. You could very well qualify for some state support. Thank you, Ben. Okay, Francesco, turning over to you. You lead a different company, also on the cutting edge, trying to make more sustainable industrial processes. So can you tell us about your solution?
100%. So first, I really want to acknowledge and thank the organization for setting this event up, because very often we find ourselves flying all over the United States and all over the world to join events like this, and now having something in town that acknowledges the excellence in Boston, in Massachusetts, is really wonderful. So really commuting here on a bike was fun today for this event. But to highlight really what osmosis is doing, need to clarify first what the problem that we're solving. And the problem that we're solving is that of chemical and molecular separations. So separation processes, when you try to purify, unmix molecules from one another, they represent one of the biggest costs for the manufacturing, chemical, petrochemical, and the energy industry. And they add up to around 15% of the world's energy consumption and carbon emissions associated with these processes. And this is because we rely on thermal processes, very energy-intense processes, to make these separations happen that are literally everywhere. So really, at Osmosis, what we developed is an alternative to these processes, which doesn't rely on doesn't rely on heat, but operates as a molecular filter. So you really you can separate molecules from one another based on their size. So you have a membrane technology, it's a filtration process, basically very little energy consumption, and also reduces the carbon emissions. We found that the most unique way we could provide value and the most unmet need in the market was related to gas molecules, which are the smallest molecules on Earth and also the hardest to separate based on size, based on a filtration mechanism and approach. So that's really where our breakthrough innovation and science found a way to found a place. And two examples that I can think to really bring this home. When you think about producing low carbon molecules like hydrogen or renewable biomethane, this is really important to bring down the cost, like better separation processes and purification processes to lower the cost and make them competitive with fossil alternatives, or even to power the AI generation with revolution with helium that is now super essential for semiconductor manufacturing and industry. Like producing that gas in a more sustainable way and reducing cost is extremely important. So those are ways in which we can help.
No, that's amazing. I think you heard Governor Hurley talk this morning about sometimes climate issues that we need to solve are not the sexiest or the most exciting. No offense, but separations might be in that category, but it's so fundamental and such a core issue, and I'm so glad we have leaders like you working on that problem.
Thank you.
Okay, Laura, turning to you. So you and your team work with startups like these two all the time, and you have all kinds of support and resources, especially when they think about their manufacturing challenges. So can you tell us about some of the barriers to getting these innovations to scale and into industry where we need them?
Absolutely, thank you. We don't just work with companies like Florent and Osmosis, we've actually all worked together. But Forge is a nonprofit that I lead that exists to help hard tech companies, innovative hard tech companies like the ones we see right next to me on the stage, specifically with their product development, manufacturing strategies, and supply chains. And when you talk about kind of areas of technical failure, there's actually a very broad area of technical failure that we're trying to address, which is simply access to the information and the resources and the relationships around scaling production. We work with a tremendous number of deeply technical founders and teams. They know what they're doing, they know their technology, but it's not unusual to work with founders that have not scaled manufacturing before. And there can be so many blind spots there. And those blind spots can actually be worse, present company definitely excluded because you've taken full advantage of Forge's support. But those blind spots can be worse on the technical side with deeply technical founders. There can be this default to, I'm technical, where I need help is building my team, it's fundraising, it's all these other methodologies. But the technical rigor of manufacturing is not the same as getting a PhD in engineering and mechanical or electromechanical. It really requires an understanding of the design for rigors, designing for manufacturing at scale. That means simplifying down your design, designing for use, assembly, testing and certifications. And when companies miss these rigors and they over-design, they under-design, they leap to production too quickly, this is where you get these very sadly very high failure rates for hard tech. So unfortunately, I don't want to bum everyone out, but on average, 97% of physical innovations fail. And when we're talking about climate tech, we're talking about a lot of crucial physical innovations. So Forge is here to buffer that, to change that, to improve outcomes for hard tech. We've worked with over 1,000 companies over 10 years, and we've even established an over 84% survival rate across all of those companies in all that time, and 20% of our companies are in scaling to full commercial production. And I think this really underscores that dedicated help around developing the product for scale, having strategies to manage your COGS as you scale, getting all of your steps to release your bill of materials together, and then identifying and connecting with the right supply chain partners really makes a difference in the outcomes. And what we want to see is more companies like this deploying their solutions at an impactful scale.
Thank you. And I think I'm going to stick with you for a moment here, Laura. So we're joined by innovators, hard tech innovators, but I want to talk about conventional manufacturers for a minute here. So most manufacturing in the US and in the world is done by small businesses. In Massachusetts, we have 6,000 manufacturers, and 5,000 of them have 50 or fewer employees. And that's largely reflective of what manufacturing looks like. It is done by small companies that have low margins, tiny teams. They're struggling to make ends meet every day. And Forge is such a unique organization because you work not only with the innovators, but also with these SMEs. So much of the sustainability progress that needs to happen at those kinds of businesses. And can you tell us about what kinds of trends you're seeing in sustainable manufacturing?
Absolutely. Poor Lily's heard this spiel of mine before pretty recently. But when I talk about sustainable manufacturing, I like to frame it in terms of the 3 Ps. So there's process, and that might be what materials you're using. Is it a circular production loop? There's production, and that might look like how are you powering the factories where you're making the product. And then there's also proximity, which is something that's often overlooked. And that means working with local suppliers so that you're reducing the carbon footprint impact of your supply chain itself and your scope 3 emissions, which can be up to 20% of the carbon footprint of producing an innovative product. Especially when we're talking about producing climate, we want to be thinking about these things, right? But when we talk about our supply chain network, we've developed this network of over 600 regional contract manufacturers and suppliers that want to work with innovators like some of you in the room, which is not where all contract manufacturers and suppliers fall. Unfortunately, it is thin margin. It can be very risk averse. We get to see the trends in sustainability within that established supply chain network that we work with. And I'll tell you their main focus at this time is really on the production piece, and it's very much driven by business needs. Energy costs are really high. That has an outsized impact on manufacturing. So we're seeing more and more of our established manufacturers take advantage of clean processes within their plants, making sure they're using clean energy. And then the really cutting edge ones, and we do have a fair number of those in our network just because they're the ones that are opting to work with innovation and stay abreast of emerging technologies, they will not often, we have a lot of stories where they end up partnering with some of the companies we referred to them initially to help them make the thing, but then they realize, oh, I can work with this startup and they can help me reduce the use of water in production and reduce the amount of downtime of machines, or they can help me monitor and manage my energy usage. So at the very highest level, they're not only thinking about their production, but they're looking at our innovators as resources to help them further make everything clean in their processes.
Yeah, you really are, in such a unique way, Forge is bridging a gap of 2 populations that have to work together more, but that have different incentives, they have different timelines, they have different levels of capital that they have access to, and so it's such important work. One of the themes that Laura brought up was on circularity, so I'm going to turn back to you, Francesco. So materials and circularity have to be improved for sustainability in industrial processes. So what opportunities do you see for greater circularity in the separation space?
Absolutely. So for us, like a clear example where separations can help with circularity and increasing sustainability is actually every time you have gas molecules that would be wasted if you don't have something in place to recover and recycle them. So 2 key examples that I can think of now are, hydrogen, for instance, in petrochemical and chemical plants. 90 to 95% of hydrogen today is actually produced and used on chemical and petrochemical plants or refineries. And 10 to 15% of that hydrogen ends up in off gases and purge gases streams that would just be wasted or utilized for low quality heat if you were not to do anything with that gas. So with the technology that we can offer at Osmosis, we can recover that hydrogen from the off gas and circulate it back to the process. How does it help? That reduces the amount of hydrogen that you need to pull from a technology that in most cases is a steam methane reformer. So you avoid extra production of that hydrogen, which would cost you around $1.5 per kilogram of hydrogen, and would emit around 10 kilograms of CO2 per kilogram of hydrogen that you are producing. So a recovery process, what puts in place is hydrogen that has a fraction of a cost, 20 to 50 cents versus $1.5, and also reduces the carbon emission that hydrogen molecule below 1 kilogram per kilogram of hydrogen, which is like more than 90% decrease in carbon impact. And another case is biogas, which is a market that has been growing very fast in Europe in the last decade. Now even in the US is really picking up, growing more than 20%. And this is gas that is produced at landfill or wastewater plants, or also produced from food waste and agricultural waste in anaerobic digesters. So this gas would be wasted or used again for producing heat or electricity, but you can also capture this gas, refine it with the separation process, and actually upgrade it to something that we call renewable natural gas or biomethane that can have a much higher value added and can be introduced in the grid and decarbonize, for instance, a very intense asset like the natural gas pipeline and infrastructure, right? So a lot of opportunities to avoid waste and decarbonize assets in so many ways, and that really helps with circularity.
It's a great example of where there's so many opportunities for reductions in costs and increasing profit of these industrial players, and one technical solution can help them with their bottom line in multiple different ways at once. So now I'd like to take a moment to think about supply chains. Supply chains is a pretty hot topic right now with federal policies, and really since COVID, I think that's been much more visible to the public, how fundamental that is. And I think supply chains are an area where we can have a lot of local collaboration. I know these three organizations well, and all of them think very locally in addition to being global entities. And so I'd like to ask you about where you have seen success in local and domestic collaboration. So Jose, I'm going to start with you. I know Florent has had a few different creative and really unique partnerships.
Yeah, supported by you. Thank you again, MassTech Collaborative. Yeah, so just to lead into that question, another quick background into how we make our product again. So again, supercapacitors, these today are made from coconut shell activated carbon. And today, if you have a Brita filter, if you know what that is also made from coconut shell activated carbon. What we're doing here at Florent is we're localizing the supply chain and diverting waste streams of local nutshells from landfill into a solid mineral form that we then apply into our product and is used to help enable the energy transition. And so towards that end, M2I2, through that grant, it supported us in building out our our pilot plant to get commercial offtake with our customers. And with that, we'll be able to go to suppliers and create basically a commercial offtake for them so that we can ensure for them that they can build up their own capacity to supply material to us. There are existing suppliers for nutshell waste. If anyone here has ever had Haagen-Dazs or Dairy Queen or Ben & Jerry's or Friendly's ice cream, we're working with that sheller for pecan shells. And that's a great input source for us, but we'd really like to localize that. And so through the grant, we're supported in working with the Pecassit-Pokanoket tribe, which is a state-recognized tribe, and the land trusts that is building up, or rather rebuilding, because they're the original stewards of this land, rebuilding their land stewardship practice and food sovereignty to feed their people and to build a practice where they can add to the regeneration of the landscape that feeds them. And so part of that work is now investigating the adoption of food forests and the planting of nut trees here in the Northeast. So it's actually a new, I guess, revitalization that there are local and indigenous trees to this land that is now being planted in the Northeast. However, it's nascent, and we are supported to engage in these conversations right now to find the economic case to enable them to make these investments. But I'll just tell a quick story related to a tribe that's further along in the Central Valley in California. This tribe was historically supported by PG&E in California, and they actually had around a blackout every week as a tribe. And so they're operating hospitals, schools, homes, businesses, casinos. If you can imagine, having an outage every single week is pretty interrupting for you. And so for them, they went to PG&E and said, hey, can we please get better access here, better performance? And PG&E went back to them and said that they have to increase, rather they'd have to pay for that upgrade, and they wouldn't provide any performance guarantee. So the tribe instead decided to invest in their own, what's called a Tribal Utility Authority, a TUA, something that I hope to see more commonly across our country, and rather our continent. You might see it more in the coming years. But for the past 13 years, they've been owning and operating their own utility authority for their people without interruption, which puts them in the top 0.1% of utilities globally. And it's operated primarily by gas turbines, but also solar plants and batteries, and now they're investigating supercapacitors. And where this ties into the vision of a holistic ecosystem is that they also operate a shelling operation on their tribe. And so the idea is, as they produce food for their people, some of the nutshell waste can be used to make the products that go into the systems that enable energy sovereignty. And they have 60 additional tribes and nations in their pipeline that want to build out additional tribal utility authorities and build their own energy sovereignty as well. And so this is the model that we're really interested in building out, and we're seated from Mass Tech to have those conversations.
Great. I mean, the thing I love so much about Florent, I talk about you guys all the time, is that if we don't use this moment where we have to rethink so much of how we produce things to increase equity and increase inclusion of populations that have been neglected by the modern world, then what are we doing, right? And so I love how forward thinking and how central you've made that to your mission. So we have about 5 minutes left, so if there are questions from the audience, I'd love to open it up to that now. I can ask these guys questions all day, but I'd love to hear from anyone in the audience instead.
Yeah, so great question. Something that we really like about membrane technology is that it's a modular technology, which means that you can build something as small as really a single module, which you can call it a pilot. That would be that's actually our pilot next year is going to look like. Up to hundreds or even thousands of membrane modules, right? So it's a technology that can both fit a very strong decentralized approach, which is also an element of resilience, I believe, in the supply chain and when it comes to manufacturing, etc. But also play a role in centralized, situations, large-scale plants. So that's the power. That's the power of membranes.
I'm going to repeat that question because I'm not sure if everyone heard that. Are there gaps in Massachusetts manufacturing infrastructure and equipment that we need, that we should build here?
Yes, absolutely. And what you identify as the gap may depend on your perspective. So Forge is actually sector agnostic, although we serve a lot of climate tech companies. There are certain, of course, raw materials you can't just get here. There are certain types of manufacturing, like cut and sew, that come up occasionally that you can't get here. And then there are big swings that the state's trying to take in terms of building out capabilities to manufacture things like chips and like wind turbines and components. So there certainly are gaps, but I could have a very long conversation to answer that. I know Lily could too.
Absolutely, and I mean, since you mentioned chips, I do want to give another plug. A different part of the Mass Tech agency is leading the Northeast Microelectronics Commons Hub. So the NEMC Hub is funded by the DoD Microelectronics Commons Program and receives and distributes federal funding for chips infrastructure build-outs that is also matched by state dollars. And so if you're a Massachusetts organization that could play any part in chips manufacturing infrastructure, please reach out. You can become a member of that organization for free right now, and there's a lot of opportunities to meet potential customers and think about what infrastructure we can build out in a creative way. That funding is all about how do we do lab to fab in a more efficient way and not have to build massive foundries where it might not make sense. Other questions? Yeah, that's a great question. So how has data enabled us to do better? Jose, do you want to start? I can answer briefly to kill time while you think. I will say, this is not your question. There are big gaps in data. I think about this every day when it comes to manufacturing, because these are small businesses, many of whom don't have great websites, don't do a lot of advertising, are not super well characterized. We can capture them via NAICS codes, but otherwise they're not a population that we reach super heavily. They're not on LinkedIn all the time. And so a lot of the players that need to be in this room, I would guess, somebody yell at me if I'm wrong, skews very innovator focused. And we need really conventional industry players in the room, and so many of those are small businesses. So that's a data gap that my team is always thinking about. Like, we literally cold call and we knock on doors, and we also need the industrial processes to be digitized before they can even be made more sustainable. And so there's a lot of opportunities as we think about gathering that data to better connect them to the ecosystem.
And just to piggyback on that a little bit, being data-driven is a core value at Forge. And one of the things that we have to do to maintain and build that supply chain network is not just send them surveys, not just look at their website, but actually go and tour their factory floor to fully identify their unique capabilities, cross-applicabilities, thresholds, things you would never find in a centralized database or on the website. And then really importantly, every time we make a connection between an innovator and a manufacturer, and some of our friends here have experienced this, we follow up on both sides to get feedback so we can get smarter in those connections each time. There's a tremendous amount of data infrastructure on other things at Forge, but I really appreciate this question and couldn't help but hopping in.
It's a great question. Okay, Claire is telling me we are done. Thank you so much. So one quick plug, these are wonderful innovators that would be good to connect with. Please connect with them outside the doors so we can get ready for the next session. Thanks, y'all.
Thanks, everyone.